Hi, hello and everyone, and in this video we will be discussing some more problems as matrices, particularly in the case of eigenvalues. Okay, so before solving the problem, we will get into some basic properties of eigenvalues. Okay, so the first property which we have here is the suppose if we have a uh, trace of a matrix. Okay, trace is nothing but if you have a matrix, if you sum the diagonal elements, so sum of diagonal elements is called as trace of a matrix. Okay, the sum of all eigenvalues of a matrix is equal to sum of main diagonal elements, so we call that as a trace of a matrix. So if you take a determinant of a matrix, okay, the product of all eigenvalues, say if you have three eigenvalues lambda 1, lambda 2 and lambda 3 of a matrix, equals its determinant. Okay, if you take a determinant, so then the product of eigenvalues both are equal. Okay, so then if you take a transpose of a matrix, if you have a matrix A and its transpose AT have the exact same values. So if you have a matrix A and if you are taking a transpose, that is you are interchanging rows and column, then you will be getting same set of eigenvalues. Okay, so this is the one of the most important properties which you have to keep in mind. Okay, then we have a triangle. If you have a triangular or diagonal matrices, the eigenvalues of triangular or diagonal matrices are simply their entries in the main diagonal. Okay, so this is true for both upper triangular and lower triangular matrices. Okay, so lower triangular matrices, so these things has to be keep in mind. This is the most important property while solving problem. You have to keep this in mind. Then we have operation and powers. So if lambda is an eigenvalue of an invertible matrix A, then A inverse of an eigenvalue A inverse is an eigenvalue of A inverse. Suppose if you have a matrix A, so if you are finding A inverse, so the eigenvalues of A are nothing but lambda 1, lambda 2 and lambda 3. Then the eigenvalues of A inverse is nothing but 1 by lambda 1, 1 by lambda 2 and 1 by lambda 3, which is nothing but the inverse. Okay, if A is an eigenvalue of A, lambda is an eigenvalue of A, lambda n is an eigenvalue of A power n. So this is true for all the cases. If any integer n is greater than or equal to 0. Okay, so n should be a positive value. Okay, so even though it's a negative value, in some sense it's true because we found this, right? A power minus 1, which is equal to, which has the eigenvalues of lambda 1 power minus 1, lambda 2 power minus 2, right? Then we have a scalar multiple. If lambda is an eigenvalue of A, then k is an eigenvalue of ka of any scalar k. So if you have a matrix A, if you multiply with k, say any number, so then the eigenvalues are multiplied with the same value. So say k lambda 1, k lambda 2 and k lambda 3. So in the case of 3 cross 3 matrices, we will be getting 3 eigenvalues. Okay, so 3 cross 3 matrices, we will be getting 3 eigenvalues. In the case of 2 cross 2 matrices, we will be getting 2 eigenvalues. Okay, so depending upon the order of the matrix, we will be getting the number of eigenvalues. There may be same set of eigenvalues. Say we have 3 eigenvalues, we will be having 2 equal eigenvalues or 3 equal eigenvalues. So that is also possible. So it signifies the most important part in while finding the independent and dependent independent eigenvectors. Okay, so for now time being, we will be discussing eigenvalues only. Okay, then we have invertibility. If a matrix is invertible if and only if its eigenvalues are non-zero. Okay, if you have a zero eigenvalues as 0, then that matrix is not invertible. What happens if eigenvalues become 0? Determinant of A is equal to 0. So as a result of that, we are not able to find the A inverse, right? So this is more elementary. A inverse is equal to 1 by determinant of A and adjoint of A, right? If determinant of A becomes 0, things will become infinity. We are not able to find the inverse. So similarly, in the case of eigenvalues is nothing but the product of eigenvalues is equal to determinant of the matrix. So if that becomes 0, we already know that the determinant is 0, right? Then we have a singular matrix. If a matrix has at least one 0 on eigenvalue, it is singular. Okay, so one zero eigenvalue, if any one of the eigenvalues is 0, so from initial stage itself the determinant is also becoming 0, so that is non-invertible. Okay, then we have a symmetric matrices. Real symmetric matrices always have entirely real eigenvalues. Okay, so we will be having only real eigenvalues in the case of symmetric matrices. So skew symmetric matrices have eigenvalues that are purely imaginary or 0. So this is most important, keep this in mind. Okay, then orthogonal matrices have eigenvalues with an absolute value of lambda equal to what? So if you have an orthogonal matrix, then the absolute value of determinant, what is meant by orthogonal matrix? A dagger is equal, sorry, A transpose is equal to I. So if you take A, and if you interchange the rows and columns and multiply with A, you will be getting the identity matrix. Okay, so this is how these are the some properties of the matrices and which is related to the eigenvalues. Okay, now so here we have some basic ideas here. Okay, so right, so in the case of first question, okay, let me write here. Okay, so we have three equations and two unknowns, three equations and two unknowns. Okay, so in this case itself, this property itself, we are able to say it is inconsistent, because if we have three equation and three unknown, we will be having unique solution, or two equation and two unknown, we will be having unique solution. But here we don't have any those properties. Okay, now we have which of the following is false. If A is symmetric, then here A prime signifies the transpose which is equal to A. This is the property of symmetric matrices. So this is the property of skew symmetric matrices. And if a matrix so is nilpotent, so if you multiply this 36 plus 36, so which is equal to 0, this is also a nilpotent matrix. This is also correct, this is also correct, this is also correct. So obviously this should be a false option, false false one, false statements. Let's check. So they give this matrix is Hermitian. What's the property of Hermitian matrices? A is equal to A dagger. So what is A dagger? We have to find the conjugate and we have to take a transpose. Okay, so if you take a conjugate, we will be having minus I, 1 plus I, and we have minus 1 plus I and plus I. Okay, then if I interchange rows and columns, minus I, minus 1 plus I, and we have 1 plus I and plus I. So this is obviously which is not equal to A, which is the A transpose, sorry, A dagger, which is not equal to A. So we will be having, so this is equal to, okay, so this is not a Hermitian matrices. So option D is correct. The matrix here, you can note it down that we will be having entries in diagonal matrices as 0, entries in diagonal matrices as 0. So these matrices are nothing but skew Hermitian matrices. So if the diagonal elements are purely 0 or imaginary, we call that as a skew symmetric matrices, so which we discussed in initial slides itself. Okay, so let I be the unit matrix of order n, that the adjoint of 2i is equal to 2k power minus 1. Okay, so we have a property called the adjoint of, just a minute, so let me write here. So adjoint of C is some constant which is c power n minus 1 edge of A. Okay, adjoint of A. So this is how the property goes. Okay, here we will be having 2i, so adjoint of 2i, which is equal to 2 power n minus 1 adjoint of I, right? 2 power n minus 1 adjoint of I. Now now let's get into another property. Okay, let's other properties, that adjoint of identity matrix which is equal to the identity matrix. Okay, so let's write for which is adjoint of, in this case adjoint of I is equal to I, so 2 power n minus 1 which is nothing but I. Okay, so if I put adjoint of 2I is equal to 2 power k I, then we rewrite 2ki is equal to 2 power n minus 1 I. So k is equal to n minus 1. So option C is correct. If A is a skew matrix of odd order, then the determinant A is, so if it's a skew matrix, okay, obviously skew matrix, the entries in the diagonal matrices are 0. Okay, entries in the diagonal matrices are 0, then the determinant of A is equal to 0. So what is the idea of another skew symmetric matrices? Aij is equal to minus Aji. If you take a transpose and there will be a negative sign there, okay, so you'll be having determinant as 0. Okay, if A and B be the two matrices such that AB is equal to 0, the product of two matrices is 0, they gave that A is non-singular. What is non-singular? If you find the determinant of A, so that is not equal to 0, then they gave that AB is equal to 0 and A is non-singular. Obviously B is a singular matrix, then only AB is equal to, AB will become 0. Okay, right. If A is equal to, they gave the matrix, then which of the following is false? They asked for which of the following is false, right? Right. So try to answer this question and give your answer in the comment box. Okay, I will give you the answer for this question in upcoming videos. Right. So if A is equal to, they gave the matrix, they given the matrix, then and I be 3 cross 3 matrices. So I is the identity matrices. M is equal to I minus A. M is equal to I minus A. Then the rank of M is, they asked for rank of M. So let's find for M. M is equal to, I is nothing but the identity matrix. Okay, so let's write the identity matrix. Then we have a minus sign here, and we have 5 0 2 0 1 0 and minus 1 0 minus 1. Okay, so let's write for we have minus 4 0 minus 2 0 0 0, then we will be having minus 1 minus 1 plus 1, yes, plus 1, and we will be having 0 here, we have minus 2. Okay, so in the case of this, so we will be having, it's a 2 cross 2 matrices, so these two matrices rows are unique. Okay, so answer is 2. If there is a non-zero minor of order R of the matrix A and all the minors of the higher orders are 0, minus of higher orders are 0, then in this case rank of matrix A is equal to R. So R is the order of the minor matrices. Okay, so those matrices have a non-zero minor, so obviously rank of A is equal to R. Okay, which of the following is false? So they asked for false statements. Okay, so a square matrix, idempotent matrices, we have A square equal to A, we call it as idempotent matrices or idempotent matrices. So a square matrix A be an involutory, so the matrix A square is equal to I. A matrix A can be an orthogonal matrix, then the for the condition for orthogonal matrices A transpose is equal to I. A square matrix being nilpotent, obviously A power n is equal to 0 or A equal to 0. So obviously option C is false. Okay, so this is also true. So this is the correct option. Okay, and we have a matrix. They asked for lambda 1 plus lambda 2 plus lambda 3. So lambda 1 plus lambda 2 plus lambda 3, which is nothing but the trace of the matrix, trace of matrix A. So here we have a matrix. So we have minus 2, minus 10, plus 14. So answer is nothing but plus 2. So option B is the correct answer. So the matrix of A, we have a 2 cross 2 matrix. The eigenvalues of 4A inverse plus 3A plus 2I are. So they asked for, suppose we have a matrix. So we have a diagonal elements. So it's a lower triangular matrices. So the eigenvalues of A are 1 and 4. Okay, so they asked for the eigenvalue of 4A inverse plus 3A plus 2I, right? They asked for 4A inverse plus 3A plus 2I, right? So now what we have to do is we have to find for A inverse. Suppose we have eigenvalues as lambda for matrix A, then for A inverse eigenvalue is nothing but lambda inverse, right? So let's have 4 as eigenvalue. Let me choose that 4 into 1 by 4 plus 3 into 4 plus 2i. 2 is I is the identity matrix, which is 1. Okay, so this becomes 1. So 1 plus 12 plus 2, which is 12, 15, 15 in this case. Okay, 15. So we have three options which carries 15. Obviously B is not an option. Okay, let's find for 1. So for 1 we have 4 into 1, 1 by 1 is nothing but 1, so plus 3 into 1 plus 2. So we have 12, 12 plus, just a minute, sorry, 7 plus 2, which is 9. So 9 comma 15 is the correct answer. Option C is the correct one. Then we have a matrix A which is defined. It's a, C, note it down, it's a upper triangular matrix. So the eigenvalues are nothing but the diagonal elements. Okay, 1 minus 2 and minus 3 are the eigenvalues. Okay, they asked to find for 3a square, eigenvalues of 3a square plus 5a square plus 6a cube. Okay, so let's check. um, we have to at least find for two elements. For two eigenvalues we have to find the eigenvalues of this given equation. So this equation will be the characteristic equation for this matrices. Okay, right. So we have 3 plus 5 and plus 6 plus 1. So 3 plus 8, 9, and we have 15. 15 as option for first eigenvalue, and for minus 2, 3 into minus 8. So we have so 3 into minus 8 plus 5 into 4, 5 into 4 plus 6 into minus 2 and plus 1. So which is equal to 8 3s are 24 minus 24 plus 20 and minus 12 plus 1. So we will be having 36 plus 20, 36, sorry, yeah, 36 plus 20. So 36 plus 20. So I think I made 8 3s are 24 minus 12, right? So 36 plus 20, 21. So we'll be having 15. Okay, so we'll be having minus 15. So we have 15 and minus 15. So we have to find for these two equations. So because 5, 15 and minus 15 is there, obviously these two options are not valid options. So we have to find for this third one. So we have to find for this third one. Okay, so let's just a minute, let me have some space to find to write all these equations. Okay, right. So we have 3 here. So we have 3 into 27, 3 into 27 so we have a minus sign there. This is minus 27 plus 9 5s are 45, and we'll be having 6 into minus 3, which is minus 18, plus 1. Okay, so 8 3s, 7 3s are, what is 7 3s are? 7 3s are 21. We have 2, 3 to 6, 71 minus 71 plus 45 and minus 18 plus 1. Okay, 71, we have 71, 18, which is nothing but 89. In 89 we have to subtract, uh, 46. So we have 46, and here we have minus 89, so we have 3, and just 43. So I think I made some mistake here. So 21 3 6 7, so this is 81, so this is 81, this is 81, this is 99, so obviously answer is 53. So we'll be having minus 53 here. Okay, so option A is the correct option. Okay, right. So two of the eigenvalues of a 3 cross 3 matrix whose determinant is equal to A. So sorry, 4. So lambda 1, just a minute, sorry, we have lambda 1, lambda 2 and lambda 3 equal to 4. So we have two matrices, two eigenvalues, 1 into 2, and we have to use minus 2 now to get 4. So the option is A. Otherwise we are not able to get this 4. Okay, then if a square matrix A has an eigenvalue lambda, then the eigenvalue of a matrix K A power T, T is the transpose. Okay, if K is not equal to 0 and it's a scalar, then the eigenvalues values is nothing but K lambda. Okay, it's nothing but K lambda, right? The eigenvalue of a square matrix A is lambda equal to 0, then A is a singular matrix. Okay, A is a singular matrix. Okay, so if eigenvalues of a square matrix is lambda is equal to 0, and determinant is nothing but the product of eigenvalues, lambda 1 into lambda 2 into lambda 3. Okay, so this follows the property. Okay, then the matrix A is defined as A is equal to, please note it down, it's a lower triangular matrices. So lower triangle, for the case of lower triangular matrices, the diagonal elements are nothing but the eigenvalues. So A square, we have minus 1 square is 1, we have 9, and we have 4. So 194 is nothing but the eigenvalues, that is nothing but the square of the eigenvalues. And A is equal to, if the matrix A is equal to, they gave the upper triangular matrix, then they asked to find for A square plus 5A plus 8I. So try this and comment the answer in the comment box. Okay, and here we have a matrix A has the eigenvalue of lambda I not equal to 0, then A inverse minus 2I plus A is as eigenvalue. So say the matrix A has the eigenvalue of lambda, then A inverse has the eigenvalue of 1 by lambda. Okay, so for this we can write 1 by lambda minus 2, because I is the identity matrix. For a matrix A, we will be having the eigenvalue as lambda. So we will be having 1 by lambda minus 2 and plus lambda. So option B is the correct answer. Sorry, option B is the correct answer. Okay, next. The eigenvalues of matrix A are 1 minus 2 and 3. The eigenvalues of 3i minus 2a plus a square. Okay, so in the case of, let me evaluate for minus 2 and 1. Okay, let me evaluate for 1 first. Okay, so we will be having 3 minus 2, 3 minus, and we have a lambda of minus plus 1 and plus 1. So we will be having 3 minus 2 is 1, 1 plus 1 is 2. So the first eigenvalue is 2. Obviously B and D are the are invalid options. So for option minus 2, let's find the eigenvalue. Okay, so 3 minus, and we have 2 into 2 minus 2, so plus 4 plus we have minus 2, so we have 7 minus 2, which is equal to 5. So 5, let me check, so I think I made a mistake. Okay, so 3 we have 2a. 2a is 2 into a is plus 4 and a square is plus 4. Sorry, a square is plus 4. So we'll be having 4 plus 4 is 8. 8 plus 3 is 11. So answer is 11 here. So option A is valid for 2 comma 11. Okay, so the determinant of 3 cross 3 real symmetric matrices, that is 6 if two eigenvalues are 2 and 3. Okay, so they gave the determinant, so the product of eigenvalues is, that is 6. So 2 into 3 is equal to 6. Okay, if you multiply with 6, then only we will be getting 36. So option B is correct. Okay, the eigenvalues of, here we have a 4 cross 4 matrix. So the eigenvalues of matrices are, they asked for the eigenvalue. If you take a trace, the trace of a matrix is nothing but 0. Okay, trace is nothing but sum of diagonal elements, which is equal to sum of eigenvalues. So if you sum the eigenvalues, okay, then that should be equal to 0. So none of the option will become 0 except A. So if you add minus 2, minus 1, plus 1 and plus 2, this will become 0. Okay, so we will stop here. So if you have any queries or any comments, please leave your comment in your comment box and share with your friends who are preparing for mathematical physics or CSIR NET or TRB examination. Thank you very much. Let me have some discussion on classical mechanics in upcoming videos. Thank you.